that, it's expensive to have such security yourself as Ethereum provides. So that's a pure business decision. Like alignment is not like we worship Ethereum, or it's a rational thing to do because it provides the best security, and it is now maybe even underpriced how much we pay for that kind of security. My personal opinion about these L1s is we need to see what kind of L1s they will build in the end. It somehow sounds like if it's a permissioned set of validators, then it's not really what we call L1, but rather like corporate chain or blockchain, which of course has its own reason to exist, but probably is not the best thing to build. But we need to see for what is the demand.
Okay, so welcome to today's episode of the Canonical Pod. Today we have Akaki with us, and Akaki is a researcher at Off-Chain Labs. So first of all, welcome Akaki. And
Thanks.
Off-Chain Labs, we know, is sort of responsible or is really associated with Arbitrum, right? So I know there's some strong association with Off-Chain Labs and Arbitrum. And I was hoping we can start off there, Akaki. Can you tell us exactly what the relationship with Off-Chain Labs and Arbitrum is?
So hello, everyone. So Off-Chain Labs is a company that built Arbitrum chain. So that's the simplest relationship between these two. And at this point, it's the company that provides service to Arbitrum chain that is governed by Arbitrum DAO. And so whole company is working around this main product. But Off-Chain Labs does other things too. Maybe you've heard about Prism, which is largest consensus client for Ethereum chain. So there's some large team inside Off-Chain Labs that does Ethereum consensus. But that's the relationship in simple terms.
So you said that Off-Chain Labs sort of manages the Arbitrum chain according to the DAO, but does that mean that the DAO can decide someone else can sort of manage the chain in the future?
Yes, absolutely.
Okay.
DAO is in full charge of the chain. Everything that Off-Chain Labs does is approved by DAO or asked by DAO. And they can, in principle, decide on someone else doing it too.
Wait, so could you clarify that a bit more in terms of like at the technical level? So for instance, so let's say the Arbitrum DAO approves a particular kind of upgrade. What role does Off-Chain Labs then play? Meaning like it's sort of effectively an offline service, but then whether the upgrade takes or not would still be dependent on the DAO? How does that work exactly?
So there are some, let's say, technical things that Off-Chain Labs is entrusted to do updates, especially if there are some small bugs or inconsistencies. But that is already approved. But if there is some or any major upgrade that affects users in a significant way, Off-Chain Labs needs to make a proposal, and there is some temperature checks and all the voting process. And then if DAO votes for it positively, only then it is implemented and upgrade takes place. Or also sometimes there are some, I mentioned these temperature checks so there is discussion on some forum, which I personally, unfortunately, don't follow too much. So I may not be the best person to talk about this from Off-Chain Labs. But so there are some people who follow that. So there are some modifications suggested by some ecosystem members, and then upgrade changes a bit. But also I think there are upgrades coming from other parts, not only Off-Chain Labs. But I would say if it's tech side, it's probably 100% coming from Off-Chain Labs. But there are many other initiatives, and some of them are not coming from Off-Chain Labs.
Okay, but so actually part of what I'm curious about is in some sense how the canonical chain is determined. And what I mean by that, for instance, is like, so if I take an L1 context, like let's even say Bitcoin, right? Like, so the miners in some sense are ultimately going to decide whether a particular upgrade actually takes, because they're going to decide which chain they're going to be mining on, right? Obviously in the L2 context, there's not really a validator set. Of course, there's a sequencer. So
there's
I guess
contract.
there's a contract.
Yes, there is a smart contract governing Arbitrum chain on Ethereum. And that
I
you
see. Okay, that's the link. Okay.
yes. So and all the funds are breached through that contract as well, and fraud proofs goes through that contract, and data availability also works through that contract.
Okay. Fair enough. Okay, makes sense.
So can anybody come up with a their own company to do sequencing for Arbitrum and then propose a vote to say, hey, I want to do sequencing on Arbitrum, and the DAO can say, okay, I'm going to let these guys do it, and then
Yes.
Off-Chain Labs will no longer be sequencing.
Yes,
Okay.
absolutely. That sounds like can happen.
Has there ever been any competition to be the sequencer?
I haven't heard.
Okay.
I mean, it's a complicated job also. It's not
Yeah.
like
Yeah. Not that I want to do it.
Yeah. So I don't think there are many companies that want to do or can do that job. But yeah, obviously, if there is one, they can propose and convince DAO that they can do it better than Off-Chain Labs, then they can get it, yes.
So I guess we've just been talking about the Arbitrum layer 2, but Arbitrum is it's like a whole ecosystem. And I was wondering if you can help us understand what are the things in this ecosystem. Like, it's like a lot to keep up with. Like, what is the Arbitrum Orbit? What is Arbitrum Nova? Like, how do I categorize the different things that are coming out of Arbitrum? And I assume Off-Chain Labs are the people building all of these. Is that correct?
Yes, those things that you listed for sure, yes. So there is Arbitrum 1 that is, probably the most famous one and has the highest number of users and liquidity deployed on it. And there is Arbitrum Nova that is very similar to Arbitrum 1, except the data availability is not through Ethereum, but there is this Anytrust committee. So it's a committee of multiple parties. At some point, it was more than 10, but right now I don't know how many parties that promise to provide data availability. And if at least one of them provides it, then it works well. Only if everyone goes down and doesn't provide it, then there is a problem.
So is this a permission set of nodes that
yes,
promise to
for
provide?
Arbitrum Nova, yes. And so then there is a tag, both of them, which is called Arbitrum Nitro. That is a fork of, let's say, Ethereum, EVM, and then there is also some extra things in it. But it's a tag that can do execution and then post data and fraud proofs that it can do. And that tag can be used by any chain. And let's say chains that use that tag, Arbitrum Nitro, and then post on Arbitrum 1 are Arbitrum Orbit chains. So these are so-called L3, layer 3 chains that are using Arbitrum stack and use Arbitrum as their underlying layer, like Arbitrum 1 uses Ethereum. And so there are also L2s in parallel to Arbitrum 1, which I don't have list now, but they exist, and I think there will be more that are also using this Arbitrum Nitro stack, tech stack, and they don't need to host on Arbitrum 1, but host on Ethereum or some other chain and use fraud proofs, but then they need to pay some percentage of fees to the DAO. So that's the agreement. But otherwise, they are independent from Arbitrum. And the Orbit chains don't need to pay any fees to DAO, as far as I'm aware.
So
Okay, you go for
yeah. So
a lot of questions there.
Yeah. There are a lot of questions I'm thinking of right now. I mean, I guess part of it is, to the extent that things are open source, it seems like people wouldn't have to pay anything. So I guess one question, so I guess implicit in what you're saying is that it's not all open source, right? If people are paying the DAO.
Yeah. So,
but then go ahead.
So again, don't take my word as a law, but if you're posting on Arbitrum 1, then there are no fees. So if you are L3, but if you're using this tech stack to be an independent rollup, then you need to pay 10% to DAO. Yeah, so there is some mechanism to do that. I don't know
how
exactly.
Is that enforced? Like what I'm saying is, so I guess the tech stack is not open source. Like why can't people just use the tech stack without paying the DAO?
Yeah, I
just
guess you can do it. Yeah, I guess you can do it. Yes, but there would be some. Yeah, I don't know what will follow to that.
Is it protected by a
technical,
license?
Right. So
probably yes.
Okay. But then why would I pick? So I guess you're saying like this Arbitrum ecosystem has like you can either become a layer 2 and pay the DAO, or become a layer 3 and post to Arbitrum 1. But then if I become a layer 2 and pay the DAO, why don't I just like maybe we can get to this part after actually. Like why do I pick Arbitrum and not OP Stack? Just make my own layer 2. But maybe we should leave that for after, because I actually want to know a little bit more about this thing that you said, the layer 3 ecosystem. And yeah, so like, is that what the Arbitrum orbit is? And
Yes. So
what?
Arbitrum orbit is, as what word says, it's orbiting around Arbitrum 1.
Okay.
And the planets on that orbit are layers 3s.
Okay.
So these chains.
But what exactly does it mean to be, from a technical standpoint? Is it really just replicating the relationship between the L1 and L2, but now it's L2 and L3?
Yes, in some sense. But what they can do, they can have their own sequencing rules. So you were mentioning if someone wants to have new sequencing rule or new sequencer. So you can have your own sequencing rule as L3. You can have, you can modify some of the execution logic, and you can have even different fee structure for transactions. So you can modify all these components, but still use the same stack. And I think that's why they choose to have their own chain for sequencing, basically.
So when I think about a layer 2 in the Ethereum ecosystem, I think about the primary advantage relative to Ethereum as being speed. It sounds like you're saying when we think of a layer 3 in the context of a layer 2, that's no longer kind of an important differentiator.
Speed and cost. Those are the two things I think about.
Yeah, so rollups are faster and cheaper. So what's the question exactly?
But but so I'm saying, if we're trying to think about, if we're analogizing layer 3s to layer 2s as related to layer 2, as related to the relationship between layer 2s and layer 1s, it sounds like, based on how you describe the layer 3s, that sort of the economic impetus to have them is very different than the economic impetus to have a layer 2, where the primary impetus to have a rollup seems to be, we want a faster chain, which then also leads to typically lower fees, as Brad was just saying. But it sounds like you're saying when you build a layer 3 on a layer 2, it's not likely that you're concerned that it's too expensive to transact on the rollup or that it's too slow. You're fixing for other things, for other forms of customization.
Yes.
But
sequencing is the big part of that, yes. Like on rollup, layer 2, you obtain, as an application, you obtain fixed ordering of transactions and execution, while on layer 3, you can decide on.
It's I guess the operator of the layer 3 that's deciding on the rule, right? Like, because
yes.
part of what I'm saying is, like, in some sense, everybody cares about the downstream to the consumer side, right? So like the advantage of doing a layer 2, if you create a layer 2 and nobody uses it, then okay, you control the sequencing, but that's not actually, well, great. You control your empty chain. And so at the same token here, presumably when you go to a layer 3, you're thinking about, well, okay, we can do things in terms of the discretion of the sequencer that will make it appealing for people to use our chain. We get the advantage, I suppose, of the
you
speed.
Also may save on costs as a layer 3 instead of being layer 2, because as a layer 2, you need to post, let's say, batches before there are blobs with some frequency, even to have a sequence. So there is some fixed costs also to posting, and on layer 2 to post, that fixed part will be much cheaper. So that would be another advantage of having layer 3 for data availability and posting.
You're posting on the layer 2, but the layer 2 is posting on the layer 1.
Yeah, but it's aggregating across different parties. While if you're layer 2 yourself and you have little usage, then you have to do it yourself.
Okay, but so actually, could you provide maybe a concrete example of the most prominent layer 3 as a way of making concrete kind of like what the benefit is, for instance, of that?
Concrete examples, I think you can check on this rollup.
L2 beat.
Yes. No. Rollup.
L3 beats. Just kidding.
No.
L2 beat has L3s on there,
Uh,
but maybe it's not the optimal.
Yeah, so it's rollup.wtf. So
That's excellent.
you can see all rollups, and there is a list of Arbitrum Nitro, so layer 3s. And yeah, you can check out the most used ones by transactions or
I see. Yeah,
yeah.
you can
So
pick the
there are
Arbitrum Nitro stack.
Very old school looking website.
yes, that's the best part.
Pepe Unchained. Okay.
So
I
these
think
are
I
very fast chains. Also, they sometimes even have faster block times than Arbitrum 1. So like 0.1 second, which is 2.5 times faster than Arbitrum 1 blocks.
Right. Maybe there's something that we're not talking about. I didn't think about until you guys were talking and we started talking about L3s. Is this notion of interop? And I'm like, can you like tell us more? What does it mean? What does interop mean for you and Arbitrum? And what is what are the advantages of being part of the Arbitrum ecosystem in terms of interoperability?
Yeah, at this point, actually, I don't have very good definition of interoperability because really different people use it for very different things.
Mhm.
Yeah, for me, it's like accessing other chains state as fast as possible would be good interoperability. So from one chain, you access another chain's state, and then you can base something on this chain based on the state of the other chain. And so then there are many different solutions proposed, and that will be probably much easier to do on the orbit level because everything is similar. But then if you go next, probably it's easier to do on Ethereum ecosystem because still there is EVM everywhere. There are some differences, of course, in these forks, but it's still quite similar. And then people also build their own chains on top to provide this interoperability even between completely different chains. And that is also, some kind of an interoperability probe. Yeah, so that would be the definition for me, maybe.
Do you guys have take any have you made any technical decisions? Because I think this is something I've heard Ed Felton speak about, like synchronous and asynchronous, these type of distinctions with interop. And I'm wondering have you done any research in this area? And
So there is research done in our group, but I'm not working actually on that, so cannot say much. But there is some active research going on this, and not only research. There is some maybe the implementation.
Okay.
But yes, synchronicity. What would be the difference between these two in your mind?
I heard Ed Felton talk about, he calls it the difference between like stop and wait, where basically you need a chain to stop so that you can pass the info to another chain before you proceed to the next block. I think he was arguing against it, but don't quote me. Don't quote me quoting Ed.
Yeah, that sounds like by design, but maybe there is no other way.
So a bit turning back to something we were touching on a little bit earlier, because we sort of alluded to this point about differential costs across layer 1, layer 2, layer 3. And I think, we tend to take for granted that it's cheaper to do things on layer 2 than on layer 1, because empirically it seems to be the case for the moment at least. But that kind of gets to, I think, sort of an important detail, which is, of course, the L2s post to the L1s, and the same with the L3s, I guess, are posting to the L2s. And so essentially, when you do things on a particular layer, the pricing of the gas on that layer should kind of ideally internalize the subsequent costs that, say, the sequencer is going to pay to post to the layer 1. And so I suppose ultimately there actually is kind of some complication to thinking about how to set gas prices on beyond layer 1, let's say. And so could you tell us a little bit about how gas pricing works on L2 and kind of how it relates to things like congestion on layer 1 in the blob space?
Yes. So the layer 2s have two parts of the cost. One is L1 posting costs, or L1 code data, but now blobs cost, and L2 execution cost itself to avoid congestion on L2. That right now on Arbitrum is very similar to Ethereum with some modification, but it's some EIP 1559 style pricing works there. The difference is, so target is higher per second. So it's 7 million instead of per second. Ethereum now would be like 4, maybe too optimistic. So in 12-second blocks, now it's 45 million. Yeah, let's say 4. So it's higher per second. So 7 million gas per second. And also there is no limit that is double the target. So limit is very high, but it's still bounded by the laws of physics. But it's much higher than 2 times the target. What it matches is when the limit is 2 times the target, then the price increase is in relative terms the same as on Ethereum. When maximum is achieved, it's like 12% increase on the price for the next round, for the next block. So that's very similar on Arbitrum, but also block times are much shorter. It's 250 milliseconds instead of 12 seconds. So that you need to take into account. But anyway, these are constants we are talking about. There's another part that is L1 call data that needs to be priced. And when the transaction comes, of course, the call data is posted compressed. That's where the major savings come in for the call data. That transaction is, so there is some heuristics to approximate how much this transaction will take space in the posted data. And then what is tracked is what is the balance of the batch poster, because we cannot access the L1 fees at the moment. We can only access it. So in a trustless way, we can only access it few minutes later, like 6 minutes later or 12 minutes later. Yeah, I would say 6 minutes because it depends on this epoch of Ethereum. So we pay depth so this transaction pays depth of the batch poster if there is a depth, or takes advantage that there is some profit. But the ultimate goal is to have budget balanced mechanism. So just to cover the costs of batch poster. So that's the mechanism. And in this rolling basis, so there is always some debt or some profit, but in the long term, it gets equal to 0.
I see.
So that's how pricing works.
Actually, could you clarify a little bit on the posting, exactly what's happening there? So for instance, like the, okay, so there's 2 sort of fee markets on layer 1 Ethereum, right? One is for sort of the typical execution data, but you can also post data there. And the other one is in blobs, right? And so when you made reference to like compressing the call data, were you like making reference to posting posting?
Yeah, so before it was call data that we were compressing our raw data into, but now we are compressing into blobs. But still, you can track how much is the, let's say, budget of batch poster.
Right.
In either case.
Sort of one question is, so you earlier alluded to like the Rollup smart contract, right? And so there is also like a state transition that happens on the Rollup state, the smart contract, right? So that wouldn't be a blob posting, right? That would have to be kind of like a regular.
That's the whole advantage of Rollup, that execution happens off the chain. Yes. Yeah, so there is state transition function that is basically very similar to Ethereum state transition function. That's how execution happens on a rollup. And on the main chain, we are only hosting the raw data compressed and from time to time the state root. And then there is fraud proof about that.
Right. But I meant like the Rollup smart contract itself also has to have a state transition from time to time, right?
Yes, but that is not done in the execution environment. It's more like that's the optimistic rollup, which someone posts what is the state now or the hash
but
of
so
the
who's
root.
the someone? I guess, and I'm wondering whether that at all affects the cost, the pricing of for instance gas fees.
No, so that's very, very, very little part of fees. It's like once an hour, you just need to post one hash, basically.
Okay. So effectively it's not priced because it's considered
it's priced, but it's really, really small part.
Okay.
Like less than 0.1%. Yes.
Okay. Fair enough.
But to follow up on your question, who posts it? That's the whole development on Arbitrum 1 since last year. So there was permission set of parties who could post it, validators. And now it's because of this permissionless fraud proof protocol that is called Bolt. Now it's permissionless. So anyone can post it. Still It's only few parties that post it, but in principle, anyone can post it.
What's the incentive?
Yeah, so the incentive for a malicious party would be to post wrong root, but for honest parties, there is not much incentive, unfortunately. Maybe there is some very little operating cost.
Okay, and just to clarify, because you sort of alluded to the frequency of this posting as not being all that frequent.
So data posting happens frequently. That happens at least once an epoch.
Yes.
So actually we had some optimal algorithm handle delay versus fee spike on Ethereum one. Now that algorithm doesn't need to be activated often because fee spikes doesn't happen on blobs often. But before blobs, it was activated quite often. So there was some trade-off between delaying posting, taking the delay cost versus posting at very high fees. So there was this optimization done. So that's in principle is a question when to post and how much, depending on how much data you have accumulated so far and what are the L1 fees. But right now, let's say posting happens once or twice per epoch and fees don't spike on Ethereum one, so it's not a big issue at the moment.
Okay. Sorry. So I just want to distinguish two things, right? So one piece is you're talking about posting call data, which, for instance, would be relevant to adjudicate a challenge. And the other thing is sort of asserting the state of the L2, which then can be challenged. And so so I want to clarify. You're saying the posting of the call data is frequent.
Yes, more frequent. Yes.
But in terms of asserting the state of the L2, how frequent is that?
Yeah, I think it's happening like once an hour.
Okay. But so when it comes to like the optimistic challenges and so on, so if nobody were to post, like assert a state for, then basically you can't get finality, right? Because the challenge period doesn't start from the point of, okay, I see.
Yeah, I mean, the data needs to be there and someone making claim about what is the root of the state needs to be there to even start.
But so I'm saying the state cannot be finalized until somebody asserts it, and then it triggers the challenge period, and the challenge period must lapse. And actually, so there's a related question there that I want to confirm, which is that so in theory, you could have a wrongful state that is finalized, right? Just because, let's say, Brad asserts a state that is completely wrong and nobody challenges him for a week. That becomes a finalized state.
That becomes canonical, yes. So if nobody challenges, then yes, that becomes canonical, and Brad can then withdraw funds according to that state.
Do you have a sense of the empirical frequency to which, I guess if somebody asserts a valid state, then there's no incentive to challenge it whatsoever, right? So,
unless you want to cause some delay, but that will cost you a lot, yes.
Yeah. Okay. So
it's the opposite.
Has it ever happened that somebody has asserted the wrong state, and was it challenged? Has it ever has sort of an invalid state transition ever finalized as a state?
Yeah,
or become canonical, I should say.
On live Arbitrum rollup, it has never happened. I think it happened. There was some Twitter thread that it will take me time to find. So it even went public. But when Ethereum forked, on the abandoned part of Ethereum, someone put a wrong state. And then it was successfully defended actually by our team members. But it was basically a fun experience rather than anything real. But on real Arbitrum rollup, it has never happened that anyone either challenged the right state or put a wrong state. But I think it has happened on smaller rollups, not Arbitrum related. So there is some history, but that probably L2 big people know better. Or it can be even publicly searchable.
I see. So on that score, I'm thinking right now about the trade-off between an optimistic rollup and a validity rollup, or a ZK rollup if you prefer. And actually, I seem to remember Ed Felton writing a post maybe a few years ago talking about the decision to kind of go optimistic versus a validity rollup. But could you talk a little bit about that trade-off and kind of maybe how Off-Chain Labs thinks about it?
Yeah, I think the main driving factor was costs of ZK proofs. Like a few years ago, it was very expensive to do these general universal EVM contracts and proofs. And now maybe it gets better over the time. And I think, there is even public statement from Off-Chain Labs that proving can be done at least partially by ZK proofs. And that can be integrated into even old protocol and make it simpler. Yeah, so that's the stance. So if it becomes so cheap that it just works to do it, then it will be used. There is definitely nothing against ZK proofs, or they are great. But at this point, they are somewhere in the middle. They're not very cheap, but not expensive as well. So they can be used as a sub state, or some component inside the both optimistic rollup.
So you mentioned Bold, right? So that's the dispute resolution protocol?
Yes. So there is even paper research and description of that if you are interested to check. But it's implemented already since last year.
Could you clarify how a ZK proof would fold into that? Like, for instance, like, because I mean, that's a dispute resolution protocol. So I suppose it presupposes that there is a challenge window. And I suppose like one of the big binding constraints when we think about optimistic rollups from the user side is precisely like when I'm, let's say, bridging tokens from layer 2 back to layer 1, am I going to actually have to put up with like a period? And so is there a way to leverage the ZK technology to...
Very simple integration that can happen, for example, is that if someone provides ZK proof because it's cheap and it's fast, then we take it as given, and then there is no need for delay period. If not, it's like fallback mechanism. But integrating it in Bold is a bit more complicated, and it takes quite some details to
right. So I was thinking of it as like shortcutting, and like, because you don't need the dispute resolution in effect, right? Like,
so if you can provide ZK proof, then you don't need.
Yeah.
So
as an aside, the ZK proofs in the context of like ZK rollups don't actually use the ZK piece, right? Like, there's nothing zero knowledge about them, is there?
No. It's just compression of computation proof. There is no privacy element to it at all.
Right. Okay. Fair enough.
But that was actually confusing for me for some time. So
yeah. So I framed it as a validity rollup and said ZK rollups as an aside, but then you kept on saying ZK, so I was like, let me.
I mean, it's a technology, but there's nothing zero.
I wanted to rewind to a thread that reminded me of something you talked about, Akaki, offline, is that with pricing. So I know you've thought a lot about not just like pricing for blog posting and these things, but also multidimensional gas pricing. Can you tell us more about what you've been thinking about in terms of how this applies to Arbitrum?
Yes, it actually
even
applies
Ethereum.
to all kinds
everything.
of blockchains even. So right now, resources are all converted into one unit that is called gas. And these resources are very unrelated often. So there is compute, like CPU power, that you are using to compute advanced state. There is bandwidth internet that you are downloading some data. There is state growth that is probably the most pressing, like state just grows and there is no way of stopping it. You can only slow it down by asking whoever wants to grow it pay some large amount of gas. And then there is history also that grows, just let's say raw transactions and some metadata. So there are very different resources and everything is converted into one-dimensional gas. This is the unit. And then when there is some congestion, it can be caused by some type of transactions, let's say that require a lot of compute, but you may be coming with a transaction that is not requiring almost any compute. So then why would you pay increased gas price because of some other transactions that increased the price? So if there was multidimensional pricing, like for a transaction, we could distinguish what resources it uses and then price these resources separately, like we price the gas, for example, or even have different pricing function for each separate resource. We don't need to have this target and limit that we have for gas, which was actually originally motivated by state growth. So having this target being half of the limit was motivated by state growth, that we can sustain, let's say, growth in short intervals, but we don't want to sustain it for long intervals. But for example, compute, you don't need to have target equals to half of the max. You can have, I don't know, 99% of max, because why do you want to save your computing power? Yeah, so you can have even different pricing for different resources. But even if you're using the same pricing, you can make a system much more efficient and increase throughput by not discriminating transactions uniformly on their usage, but actually look into what resources are they using and price them accordingly. So that's the main idea of multidimensional pricing, which now there is some even working group in Ethereum research, and we are also looking into this.
So by the way, it seems to me there's sort of another aspect here. So for instance, like when you think about execution, you do the execution and then you're done. But when you talk about state growth, right, we're talking about ultimately like data storage, right? So for instance, if I were to store just an int, let's say, on the blockchain, just and like, I create a smart contract with the state variable and I put it there, right? And I leave it there. Like how, in effect, like the cost that I'm imposing on the network is going to be a function of how long I kind of leave the information stored, right? And so when you think about, for instance, pricing what you were describing as state growth, I mean, what's the right way to think about that, I guess, is my question, because it seems like there's a temporal aspect, which is kind of hard, like, because we typically, all the charging is sort of upfront, like, okay, you're doing this particular transaction, and so we're going to charge you a certain amount right now, but it's not like there's a flow cost to a transaction that I do, and in some sense, that's actually the burden I'm putting on the network.
Yeah, you are asking now much more interesting and deeper question than multidimensional pricing is. So all I'm saying is much simpler. You should not charge bread a lot because you are storing a lot of integers.
No, I get that. I get that.
I agree. So how to do correct pricing of state growth, that's another deeper and more interesting question. How to do it correctly? Or you need to probably optimize some target function, which is you need to define, which we don't have. Now we just have that we know that we don't let in the worst case state to grow too much. That's the EIP 1559.
So I think part of what you're alluding to there is, like, in some sense, the real motivation for things like gas limits is precisely to limit state growth. Like, if you can only have so much gas in a block, then it's going to limit, like, maximally how much the state can grow.
So you don't need to have basically different target and limit for CPU power or computation, like real computation that doesn't grow the state, or require some download through the internet, or doesn't grow the history. So these are very different resources.
You guys were focusing on the challenge of pricing these separate resources, but I know, Akaki, that you mentioned that even figuring out how to separate the resources is a challenge.
Yes, that is challenge because of, let's say, EVM and how opcodes are operating. Like different opcode may be using different resources at the same time, and you really need to split opcode across the resources. And then there are some refunds and there are some recursive calls, and so it gets complicated, this part. But fundamentally, there are resources that are clear, and you can measure their impact of opcodes on your own computer and on your internet. So that gives you some constraints on your defined resources, and then you come up with these constraints and then come up with pricing rules not to break those constraints. And you can also come up with your own resource, which can be like, let's say L1 call data is a separate resource and have pricing rule for that. Or it's like some composite resource, not this real physical resource that you're.
Got it. When can we expect multidimensional gas fees on Arbitrum?
I think it will be in cooperation with Ethereum. I cannot say, but I hope next year.
Okay.
Sometime next year. But yeah,
Okay.
it can be a few years off my prognosis.
Right.
But yeah, things can actually move faster on Arbitrum sometimes.
Maybe we should switch to something not in the future, but something that happened recently, which I know is your expert topic, Akaki. Time boost. Yeah. Maybe you can tell us a little bit about what is time boost and like when did the change happen?
So time boost was deployed in April, middle of April. So it's already 4 or 5 months in production. In very simple terms, it's basically first come, first serve ordering rule with one party having 200 millisecond time advantage. And in real terms, this is implemented by delaying everyone else by 200 milliseconds in the sequence. The sequencer gets transactions and delays them by 200 milliseconds, so it creates a queue. But when sequencer gets transactions from time-boosted party or the party that holds this fast lane, it executes or puts in the sequence right away without a delay. So it's a merge of these two first come, first serve queues. And this fast lane is auctioned once a minute. So before the next minute starts, there is auction taking place. And so the highest bidder wins it and pays the second highest bid. So this is so-called second price auction. And that advantage lasts for the next minute. So there is also reserve price, which is 1,000 ETH. So it's right now, I don't know what is the price of ETH in dollar terms, $4.5, I think, around. So if nobody bids more than that, then there is no fast lane or privileged user, and it falls back to first come, first serve for the next minute. So that's the rule exactly.
So can you remind us though quickly what the block time is on Arbitrum?
It's 250 milliseconds.
Yeah.
So it lasts 240 blocks, this advantage.
Okay. So you said before, so you described time boost as first come, first serve with Fastlane. So before time boost was put into production, we just had Fastlane. I mean, we just had first come, first serve. So
yes.
Why was a decision made to add a fast lane?
So there was a lot to like about this first come, first serve, because it's the most natural, fairest, at least in computer science, first come, first serve is the most natural ordering rule, while blockchains are a bit weird. But in blockchain setting, people cannot, like often they don't understand what is first come, first serve. Well, this for me is much more natural ordering rule. And there is a lot to like about it. But there is also some disadvantages. And the main disadvantage is parties really try to be fast. So there is some latency competition. And they invest a lot to collocate with sequencer. And if sequencer moves, then they also move. And they really try
Your
to...
sequences in Japan, right?
I don't think I can tell that.
Okay. Okay. Go ahead.
Yeah, and then, so there is a lot of resources spent on lowering latency as much as possible. And from the protocol perspective, that's a waste. Like it goes to some web servers, some other service providers. It doesn't go to protocol, it doesn't go to users or contracts or anyone on the chain. So we initially wanted to shift some of this investment into revenue for the chain. So that was the original motivation to change it to something. Of course, you can go extreme and have Ethereum like block building process, but you know probably better than me that it has problems. And then you cannot have very short block times. There is no way you can do block building in a full permissionless setting like on Ethereum in 250 milliseconds. So we wanted something, that shifts that investment into revenue and doesn't break things. So we don't want to increase block times, at least by much. And so there was this original idea is now very different from the current time boost, even though it has the same name. But I don't want to go into those details, but there were some iterations and we arrived to this final version that I just described what it is. And one of the versions actually was on the way was what is called PG, priority gas auctions. We were calling it a bit differently. We were calling it frequent ordering auctions. But idea was exactly the same. You're bidding per gas priority fee, and then sequencer takes in block time, during block time, all the transactions and sorts them in the decreasing order of their bids. But yeah, there our problem was that if you want to have very short block times, then time advantage is substantial, like in relative terms. Like if you have 250 millisecond blocks, then your 50 millisecond latency advantage is becoming very important. So you will try to decrease it still as much as possible. Only if your block time is long enough, then maybe you care less about this 50 millisecond or 20 millisecond time advantage. Well, one idea was to increase block time a bit, but yeah, we didn't want to do that. And then with 250 milliseconds, we decided to go with this version of time boost. And yeah, so we think it has some good properties, but of course it has some bad properties also. It delays all the users by 200 milliseconds. That's obviously not good. And yeah, so there are all these considerations for liquidity providers that they now will be losing more to arbitrageurs than they would lose under pure first come first serve.
You said something that kind of contradicts what you told me a year ago. Oh, not contradicts, but it's I'm having trouble putting them together. Is that you told me to not think about Arbitrum as having blocks under first come first serve, because you just get transactions coming in and you just put them first come first serve.
Yes.
And
yes.
It seemed, and a lot of what you said, you really grounded the discussion on Arbitrum having a 250 millisecond block time.
Yes.
So now I'm having trouble putting those two ideas together.
Yeah. So blocks are just, let's say, very simply said, just a formality or a way to communicate what transactions did you receive in this time interval and in what order. So that's a way of letting the network who is listening, what is the state now? That's it. So there is no logical block building process. It's just way of communicating with the rest what is the ordering of transactions. And that is done through broadcasting blocks. So I don't see a real contradiction in a sense, except for, what is meant under block in Ethereum is very different what is meant here. So It is like block of transactions in this time interval, or ordered set of transactions in this time interval that we call block. But it looks like Ethereum block in some sense. Like it has all the headers and pointer and the state root hash as well.
So maybe reframing Brad's question a bit. So okay, what would the distinction be between just saying let's say Arbitrum puts out blocks at irregular intervals and it has only one transaction in it, meaning I get that that's not okay. So if I consider an irregular in time, meaning stream of transactions, which corresponds to the order of the transactions on the Arbitrum chain, I could also just kind of say, but every 250 seconds, I can just draw partitions and I can take whichever transactions came out in that stream and say this is a block or whatever, right?
Yeah.
So what is the advantage of saying that there are blocks every 250 milliseconds rather than just saying...
We just had this discussion actually not long ago. Why don't we just broadcast transactions separately, exactly as you said?
Yeah, exactly. Yeah.
And the problem is that there are so many transactions sometimes coming, then you need to make a pointer to previous transaction or give a transaction number, because when you start broadcasting, someone who listens to you may receive them in a wrong order. So then you need to add as much as you are basically adding to a block. So then what's the advantage? That was the question. But what can be done for sure that instead of 250 milliseconds, we can do, I don't know, seconds or 50 milliseconds broadcast. But then, of course, you run into danger that there will be too many empty blocks. So there is a trade-off here. Because with 250 milliseconds, it's almost never the case that it's empty. While if you now go with 50 millisecond blocks, then can be more empty blocks, especially in times of low activity.
Okay, I just wanted to ask one last point on the time boost thing, because you described it a moment ago, maybe a few minutes ago, as one of the disadvantages you said was that liquidity providers might face larger losses because they're effectively being delayed. Actually, I was thinking about I mean, if I understood you correctly, you're saying that everybody gets delayed by the same amount except for the person who's got the fast lane. So they're not really losing anything except to the extent that the person who's in the fast lane is the arbitrager that's running the arb, right?
Yeah, that's one way. Also, there is another thing that once there is a arbitrage opportunity, this party can now, let's say, if it has the same latency than others, can wait for 200 milliseconds instead of taking the arbitrage value right away. And that increases its value. So that's what gets added. And we observed on the data, actually, we wrote something about that quite openly, that there is quite some value into this option of waiting and not taking the value right away.
So conceptually, this actually, I mean, while maybe literally it's different, but conceptually this actually sounds a lot like the multi-block MEV discussions where, I mean, so basically what I'm saying is if I can get 2 blocks in a row on Ethereum, then I can basically choose to run my ARB on the second block rather than the first block, and maybe that's better than...
It's a bit related, but their block builder gets so much power. Here we still have private mempool. So time boosted.
I'm just saying, like from a mathematical perspective, it's a similar type of thing, which is like, look, I could run this ARB right now, or I could wait and see if I run the bar a little bit later, maybe it's more valuable to me.
Yes. Also, this is much short-lived than the other one, yes.
Okay, maybe this is a good point to switch to another topic. So I think it's also probably kind of relevant with all of the announcements that are happening recently. And the announcements are of new layer ones. There are a lot of people building new layer ones. And Arbitrum, by building this layer 2 and layer 3 ecosystem, has sort of taken this Ethereum aligned sort of business perspective, right? They're going to build on top of Ethereum. And I'm curious, maybe this is not too much of a research question, but you can share anything technical or your personal views as well. How does Arbitrum see this sort of change in the ecosystem where people are not building on top of Ethereum and building their own blockchains? Do you guys plan, how do you see this from a business perspective? And do you plan on building your own layer 1 at any point in time?
So again, to start with a very original question, we are not Arbitrum. So I don't know what Arbitrum means.
Yeah, sorry. You see that association is so strong in my brain.
It seems to be strong, yes. So but you can ask this question on the Arbitrum forum, I guess.
Okay. Well, maybe answer this question from Off-Chain Labs perspective.
Yeah, so to be honest, we never talked about this topic during research meetings or discussions, and even other bigger, wider meetings, like why are other companies doing what they are doing. But yeah, so my opinion matches, I don't know exactly what is his title, changes from time to time, but there's AJ Warner, maybe you've heard him. He's head of partnerships. He was at least at some point. I think he's chief strategist. So I share his opinion, which I heard him doing podcasts also. That it's expensive to have such security yourself as Ethereum provides. So that's a pure business decision. Like alignment is not like we worship Ethereum or... It's a rational thing to do because, it provides the best security and it is now maybe even underpriced how much we pay for that kind of security. My personal opinion about these L1s is we need to see what kind of L1s they will build in the end. It somehow sounds like if it's a permissioned set of validators, then it's not really what we call L1, but rather like corporate chain or blockchain, which, of course, has its own reason to exist, but probably is not the best thing to build. But we need to see for what is the demand.
So your answer kind of leads it raised a question in my mind, which was that Arbitrum 1 is using Ethereum for data availability, right? But as you
Yes.
pointed out, in fact, I think you said Arbitrum Nova uses something else for data availability. And so
Yes.
in principle,
I
Ethereum
mean,
is
it's not
not the only.
only data availability, it's also fraud proofs,
Okay,
like
yeah,
state
sure. But
transition.
okay, fine. But at any rate, my point is that Ethereum is not the only thing that could be used for that purpose.
Absolutely.
Now you alluded to sort of the level of security that the Ethereum chain provides, and I think it's fair to say amongst permissionless chains, Ethereum is currently probably the most secure. But for instance, if you woke up tomorrow and Solana was more secure than Ethereum, that seems to change at least the story that you were, or the reasoning you were providing. And then so part of what I'm wondering is how hard is it for, let's say, Arbitrum 1 to use something other than Ethereum? Like at a technical level, how hard would a switch be? And I realize that could also vary depending on kind of how similar the layer 1 is. But yeah, could you just clarify how hard it would be to switch off Ethereum?
Yeah, so I mean, it would require, then if it's not EVM compatible and you need to write this new governance contract, that would require new contract. And then, yes, some logic of at least implementation of Bolt needs to be completely rewritten. If it's very different, then it's a lot of work. If not, then, yeah. I mean, if it was EVM chain, then it would be very minimal changes, let's say. But if not, then no. But also another thing is most of the applications that are running on top of Arbitrum are also applications that run on Ethereum. So let's say now moving to Solana will not be so smooth, and like for these interoperability reasons also. But yeah, in principle, rollup technology you can build on other chains as well. And I think I've heard some Bitcoin rollups also. And you also mentioned that they are
Actually,
coming.
that reminds me of, or that brings forth a question that I was actually thinking of asking you earlier. But so now I'll ask it now, which is actually recently Brad and I had a chat with Kofi, who's famous for work he's doing associated with a recent upgrade that Ethereum did, the 7702 upgrade. But one of the things I find interesting is on the site Kofi's created, bundlebear.com, it shows sort of the activity for these smart wallets, but it's not just Ethereum, right? So for instance, you see the activity for Arbitrum. So the reason I'm bringing this up is, it hadn't occurred to me like when Ethereum does an upgrade, for instance, this thing about the ability to upgrade externally owned accounts to smart contracts, that something similar might happen on, for instance, Arbitrum. So could you talk a little bit about kind of that relationship, meaning, in fact, let's make it concrete. So in the case of Pectra, part of the upgrade was this smart contract upgradability. And it seems, at least from what I can see from the data, that the same sort of functionality is also on Arbitrum. But how does that work exactly?
Yeah, so there are some, I think, quite regular planned upgrades happening on Arbitrum that reflect upgrades on Ethereum. So these are, yeah, very technical upgrades. I don't even think they need DAO, but I may be wrong. I think they still need, but yeah, I'm not 100% sure. But every Ethereum upgrade is followed by Arbitrum upgrade quite closely in time.
Okay.
Sometimes maybe not needed because Arbitrum had already that functionality, but yeah, that happens rarely. Mostly it's following the Ethereum upgrade.
Okay. But so then this maybe goes back to that point about like how tied to Ethereum are you? I assume if you were switching to Solana, there's also this aspect of like an ongoing coordination with things that the Solana chain is doing, for instance.
Yeah,
So it might not
especially
be.
if many users are using same applications on Arbitrum as they use on Ethereum, then we really closely need to mirror the moving to other chain. If you keep the same applications only, somehow doesn't sound very good business. Then you need to have, other applications that are on layer 1 so that you get users in the first place, but then you completely become that layer 1.
Okay, so maybe if building a layer 1 is an Off-Chain Labs priority right now, can you tell us what are the current priorities of Off-Chain Labs?
Yeah, so as I mentioned, is multidimensional fee mechanism is one of the priorities of at least research team. And Yeah, so in general, having like better execution, and there is this stylus project which allows you to write smart contracts in other languages. I think opens doors to many different developers that are not yet on Ethereum and are not Solidity experts. And so we hope that we can onboard those developers on Arbitrum, and then with more usage, then we need to have better execution, better pricing, and so have chain ready for more users.
Wait, can you talk a little bit more about this using other languages? Like how are you doing that? Also, are other companies doing this as well, or is this like a unique Arbitrum? I mean, Off-Chain Labs, sorry.
No, that's actually part of Arbitrum now, the stylus, and it's
Okay.
part of Arbitrum tech stack, at least. So it's
Is this
basically
yeah.
extension of EVM. So you can have smart contracts and execution that is not exactly EVM. And other companies, I'm not aware, at least in the Ethereum ecosystem, but I might be wrong.
And
because
so the
there are
goal
many
of this is to
announcements.
attract more applications into the
Yes,
Arbitrum orbit.
applications that are not possible. I mean, theoretically, everything is possible to implement in Solidity, but there are very complicated logic sometimes needed to implement them, while other languages allow you simpler implementation of the logic. So that's why Stylus was created. And also, there is a lot of gas saving for certain computation, and mostly computation, especially with let's say mathematical formulas. So there have been some demos how much Stylus saves on calculating complicated formulas. And so for financial applications, that can be quite interesting to use Stylus. But I need to inquire if others are doing that too. There might be other groups also doing it.
Okay.
So, but it's basically extension of EVM, which is called EVM Plus. So Arbitrum is still fully EVM compatible, but you can do more things.
Okay. And on last question, tell us, I want to know about Robinhood, but I know you can only say certain things. So maybe nothing at all. But I guess I want to know from your perspective as a researcher, the fact that Robinhood has decided to build, well, maybe first question, is Robinhood a L2 or L3? Is the Robinhood chain a L2 or L3?
So the way I understood from public announcement is that first they deploy some assets on Arbitrum 1. So there is no other chain. So
Okay.
they will build some contracts and do some logic on Arbitrum 1. And then later they want to create L2. That was my understanding
Okay.
from the public announcement.
So this will benefit the DAO because they'll be paying the DAO.
Yes,
Okay.
I guess.
And from a researcher perspective, sort of like maybe your day-to-day or the research team, has the incoming of Robinhood chain or the expected incoming of Robinhood chain sort of created a different priority or like a new problem that you need to solve? Or have you had to do any special type of like problem solving to ensure that Robinhood chain could join the Arbitrum ecosystem?
Yeah, and actually, as you said, I cannot speak about these things, but from research perspective, I can tell you that it's like new user base, hopefully, and everything that we do in general for handling much higher usage will still apply to Robinhood in case they bring a lot of usage. So this in multidimensional pricing, same example. And so we need high throughput with the same resources if we want to keep the same requirements for running Arbitrum.
Okay. Yeah, that's as promised, that was the last question. So yeah, thank you, Akaki, for joining us today. I think this
Thanks
was
for
our
the invitation.
I think this is our most technical episode yet. So I was happy that you can get into, a lot of these topics like multidimensional gas pricing, time boost. I know this is one of your favorite topics, time boost. So happy we got to go into that as well. And yeah, also to force me and hopefully anyone else listening to maybe disassociate the Off-Chain Labs and Arbitrum connection and remember that they're two separate entities. And when I think of you, don't necessarily think of Arbitrum. Think of Off-Chain Labs.
Thank you,
Yes, that's
Akaki.
right. Thanks for the invitation.
Okay, cool.